Today we get to learn about relations. Relations are things that go together, like a relationship of two people. So a relation pairs input values with output values, and we have a couple different ways of representing them. You might see a set of ordered pairs that looks like x comma y, where x is the input and y is the output. Like in example 1, we will list the ordered pairs. You might see a table of values where all the x's are listed in a column and all the y's are listed in a column. That would be like what that is in example 1. You might have a mapping diagram, and that points arrows between the x and the y values. It looks like the thing in example 2a if you look down on your paper. And the last way we represent relations would be with a graph. That's when we plot the x and y pairs on a graph like in 2b. We call all the input values, all the x's, the domain, and we call all the output values, all the y's, the range. So today we're going to be identifying domain and range. There's a couple different ways to write down what the domain and range are, depending on what we have. We will use roster notation if you have a set of ordered pairs, or if you had something like a mapping diagram. Remember, roster notation starts with a bracket, and then you list each of the elements in it, and then you close it with another bracket. If you have a line or a curve on a graph, that means that you mean every single point on that graph, and you might use interval notation when we put the high and low numbers separated by a comma, or you might use set builder notation where you have the inequality to show that. For the first example, we're going to identify the domain and range, but first we will list the ordered pairs. Usually whatever's listed first in the table is the x value, the input, and whatever is listed second, the output, is the y variable. So all we need to do is list, in parentheses, in the year 2007, the savings account had $300. Those two go together. In the year 2008, so I'm abbreviating, the account had $350. And you would keep writing the rest of those ordered pairs. I think you probably have the hang of that. So let's go ahead and list the domain. We first start with a bracket because this is going to be a roster. We have ordered pairs, we have elements from that table, and so all the numbers in the x part of the table are the years 2007, 2008, 09, 10, 11, and 12. Notice they're in numerical order from low to high. Now we will list the range. We will start with our bracket. We need to list all the numbers in the y part of the table from low to high. So we'll start with 300, 350, 400, 450, and 500. And since 500 repeats itself, but we already wrote it down, we don't need to repeat ourselves, and we can close the bracket. There are all different kinds of relations, but only some of them are functions. The ones that are functions are when the first coordinate, which is the x, or the domain, is never repeated. So you can never have the same x value twice. So let's look at the mapping and the graph. We will write down the ordered pairs and then decide if it's a function. So to read this mapping, it says right here that this box is the domain and this box is the range. So it means the first part of the ordered pair for the x is 2. And see how that 2 has an arrow to the a? A goes in the y. Maybe you even write x and y right above. The second ordered pair will be 2, and this time it's pointing to the b. So 2 goes in the x spot and b goes in the y. And then the last one would be 2, comma, c. Those would be the ordered pairs. Now for the domain. We start our bracket, The only number listed in the x is 2. And then for the range, we have the 3 letters A, B, and C. Is this a function were the x's ever repeated? Yes, the x's were repeated. So this is not a function. Let's see if you can do B. I'll start you off on 2C. To get the ordered pairs, we're looking at a table. So again, the top values are the x's and the bottom are the y's. So I'll list the ordered pairs. To cook 2 servings of rice, you need to cook it for 5 minutes. You can keep filling out the rest of the ordered pairs, write the domain and range, and I can tell just by looking at the numbers in that top row, 2, 4, 6, 8, none of those numbers ever repeat, so this is a yes, this is a function. You can try 2D. This question is something that we will discuss in class, but my hint to you, so you can think about it, is are those functions yes or no? Compare A and B. Sometimes we don't have a table or a mapping or a list of ordered pairs to decide if the x's repeat or not to determine if something's a function. So when we have a graph, this is for figuring out if a graph is a function. We use the vertical line test. I like to abbreviate it, the VLT. The rule is, if you have a vertical line, a straight up and down line, that passes through more than one point on your graph, then the relation is not a function. It would fail. So on that circle, I just drew a vertical line through it. See how the green line intersects that red circle here and here? Since there were 2 places it intersected it more than once, it fails that vertical line test. And it doesn't matter where you draw the vertical line, it has to work anywhere on the graph. So if I draw a vertical line on this graph, I could draw over here, and look, the green and the red only intersect in one place. Great. I have to be able to draw a line anywhere on the graph and have that be true. If I draw it right there, it only crosses at one time. If I draw one right here, it only crosses at one time. So this one is a function. This one does pass the vertical line test. So it's a yes. This one was no, not a function. So I will do 3A. I could draw a vertical line right here. If I drew one right there, we'd say, oh, it only passes at one time. Great. But what if I drew the line over here? Look what happens now. Oh, it crosses it right there, and it crosses it right there. Since it crossed it twice, then the answer here is no, that is not a function. All right, you can handle 3B and 3C, and we will see you in class to talk about the rest.